let's learn about Python's inheritance system with its classes. In our conceptual introductory video, we talked about this idea of a father and son, which is a great metaphor because there's biological inheritance we're all kind of used to, and so we're going to try to mimic it through code. I'm actually going to be writing all of the content in a single module in Python just to show you that you can. At the top, I'm going to create all my classes, and near the bottom, I'm going to have kind of the operational functional code that's going to run it all in one spot, which is totally allowable in Python here. So the first thing I'm going to make is a father class that is going to contain some content soon. Let's just first have an initialization method that prints father created, just so that we know when it's created. Now I'm going to head down a little bit of space and create a son class. I'm going to define the initialization for this as well and say son created. So far, I have two classes in the same module completely allowed. And so what I can do down below is instantiate both of these. I'm going to say, oops, father, autocomplete led me astray there, and son equals son. So I've created an instance of both of these classes, and when they're initialized, they should print out their name. Father created, son created. So far, so good. So what we have here is a couple of classes that are able to be initialized. Let's give the father one more piece of information here. Actually, inside of the initialization, I want to create an instance variable. So an instance variable, I have to go to self dot so to make it that it's every father can have their own different copy of this. I'm going to set an age that the father has, and I'm going to allow that to be passed in up here, so age. So the age that the father knows about is whatever age I set it up having. And I'm going to do the same thing with the son. I'm going to give it an age and have its own age variable, instance variable set to age. But I also want to give the father a favorite introduction. And the favorite introduction is going to be, hello neighbor. Hello neighbor. We're in Canada. Put a U in there. So hello neighbor, favorite introduction. So this is just always going to be the father's favorite phrase at the start, or favorite introductory phrase. So I'm going to allow it to also say fav phrase here. And I'm going to have this print out the favorite instruction, but remember the favorite introduction, it's a instance variable. So I have to type self first to be able to access it. So my father knows something that the son doesn't so far. The son doesn't have this favorite phrase idea just yet. So when I type in father, I should expect to see the favorite introduction accessible to be reported on, but the son doesn't. Okay, the son doesn't know anything about this behavior yet. I need to remember to give them an age. I'm going to give the father 50 and the son 15 because why not? Seems like good numbers to go with. And let's run this and see what happens. String object is not callable in my line father favorite introduction. And oh, it's because I meant to actually run the method here and I just got ahead of myself. I want to say the favorite phrase. That's what I was wanting here, not just to run the variable itself. And it says, hello neighbor. I rushed myself a bit there. Father created, son created, and the father says his favorite phrase. Wonderful. So now that we know that each of these things are being created here and that the father can say something, let's get into the real content of this lesson, which is the inheritance. The son is going to be inheriting from the father. We set it up with open and close bracket and just typing in the name of the parent class inside of here. Here it's literally the parent, but metaphorically, this is the child and this is the parent. So what's going to be happening now that this inheritance is up and running? Well, I can see something that happens right away. Say favorite phrase is suddenly accessible by the son. Why is that? Because the son, because it inherits from the father, has access to all of the phrases, or sorry, all of the methods that the father is able to do, all of the behaviors. The son inherits those behaviors. Quick side note for those who studied Java last year. In Java, you might have been used to writing these like private and public access modifiers. In Python, we don't have those. Everything's just public, so everything's going to be inherited. That's all you need to know about that for now. There are ways around that, but they're really clunky. We're just going to leave everything as inherited for the time being. So what would happen if I actually try to have the son try to say their favorite phrase? We get an error. The son doesn't have a favorite introduction attribute. But the father does, and I'm inheriting from it, so why don't I have that attribute? Here's one small little quirky detail about Python. The initialization method is not directly inherited. We have to kind of tell Python when we want it to be inherited. And here's how we do so. In the son class, when it gets initialized, I'm going to enforce that I actually also run the initialization for the father class by typing in super and running the super method, and then I'm going to run its initialization method. And I need to remember that it actually wants the age to be sent. So I'm just going to send along my age so that the right age is kind of set up in place there. So here's how I actually give myself access in a child class to the initialization of the parent class. So let's see what gets printed out now, and I'll talk you through the logic here. Father created, father created. What's going on? Well, let's actually comment out everything to do with my father for now, so that we don't have quite so much information to weed through here. Father created, son created, hello neighbor. What's happening is I'm only instantiating the son, 15 years old. The son class is going to run its initialization method, but the first thing that it does is actually run the father, the parent class's initialization method first, which, when it gets initialized, actually says father created. This is proof that this inheritance is happening. In actual running code, I would comment this out later because I don't want this to show up probably, but I included it so that we could clearly see that this is being triggered from here. And then next it says son created, and then it sets up its age variable. Now, because through this super call, I actually set a favorite introduction variable in place, this is now inherited by the son because the son now has it in existence in its class. And now this is accessible by the son, which is why the say favorite phrase call actually reports hello neighbor. And in this case, the son actually got the hello neighbor from its dad. It borrowed it and inherited that value. What if I wanted the son to be able to have its own favorite introduction kind of value? Well, what if I tried to say self dot favorite introduction down in this space here? Could I set it to something else? Hey, sup. Maybe that's what it says instead. And around this code. Hey, sup. So I can actually override or kind of redefine the value of that favorite introduction and allow myself to have a different implementation of it. So cool. I can inherit it if I want to. I can overwrite the information if I want to. I want to show you one more example of something that happens in inheritance that's pretty interesting to think about. In here, I'm just going to have maybe I will say joke. So I'm going to have just a simple print message here, and I think a nice dad joke is like, why is 6 afraid of 7? Because 7, 8, 9. Classic dad joke. And it's also hilarious. I guess I'm a dad, so it kind of makes sense. So let's see what happens now if I allow my father to be the code that's operating, and then I have, instead of saying its favorite phrase, I have my father say joke. As expected, it says, why is 6 afraid of 7? Because 7, 8, 9. How about the son? Let's switch over to the son, and let's just see if that's accessible. Say joke is accessible. Why? It's a method defined in the parent class, meaning it's inherited by the child class. So it has access to it. But the son has been listening to their dad too much and has picked up his lame jokes. So can we give the son his own custom joke? How could we do that? Well, it's something called overriding a method. What I can do is actually give the son the same method that the father has. And in this case, I'm going to change the content. Oh, what's a good kid joke? I'm going to show my age here. I'm not entirely favorite introduction here. What is this complaining about? We'll deal with that in a sec. And what I want to have this say here is some other type of joke, and maybe, I don't know, ask me if I'm a tree. Ever heard of this joke? Anyone know this one? I'm just gonna say, actually, we want an escape character here for the apostrophe. I am a tree. And the way this joke works is you ask someone to ask you that, and then when they ask you, you just reply no, and then there's awkward silence. It's a classic, a pretty modern joke. So this joke asks me if I'm a tree, and what we're going to be doing here is just testing out what happens, because I see that I have my dad say joke and my son say joke. They both have the same method. So what happens when I call this son, and what did I do? Say joke self, def say joke, self, my indentation. Did I press a backspace here somewhere? Hello? What is happening here? So what we can see in our code now is that I've now defined a say joke in both spots. The dad has the say joke and the child has say joke. Oh, there's my issue. A little tiny typo here. And now that they have the same naming, I see this weird symbol appear on the side. If I hover over it, it says overrides method in father, and here is if overridden in son. What this means is that because it has the same definition of a method, the son will override and replace the functionality of the father, as if the father wasn't really there in the first place. And you'll see as I run it down here, the son is created and it's asking me if I'm a tree as the joke that it says instead, replacing the content of the father's joke. So just like a son in real life, you're not doomed to always do every behavior the same way your parent does. You have the ability to define for yourself a unique expression or unique implementation of that joke or that behavior as you see fit. So inheritance allows you to not only borrow some information from the parent, but override it, and also has the ability to initialize new instance variables that are borrowed from the parent. Or if I really wanted to, I could say, hey son, I want you to have some information about favorite Pokemon. And of course, your favorite Pokemon is obviously Charizard. And notice that this instance variable is not present in the parent. So if I go to the father and allow this to exist and go father dot favorite, oh, there's no favorite Pokemon here. But the son does have a favorite Pokemon. That's because anything implemented at the lower child level won't feed upwards to the parent. It's pretty tough to change them. They're kind of old and not flexible anymore. So it only goes one direction. The new things in the parent trickle down to the child, but the child does not trickle back up into the parent. So there's a few examples of inheritance. I'm going to make one more video on this to show you one more way that inheritance can be used in our program design.